Hello. The purpose of this video is just to go over a brief review of simple and two-step equations. So simple equations are the equations that are very friendly for us to solve. We usually do them by inspection. So something like this, x plus 4 equal 11. So we're just looking for a number that added to 4 gives me 11. So that I can see almost instantly that is 7. I really don't need to do a huge amount of math to do things like any of these equations. 20 equals x minus 5. So I'm looking for a number that when I subtract 5 equals 20. So that is 25. 3x equals 12. So I'm looking for a number that when multiplied by 3, I arrive at 12. So I can easily ascertain that that would be 4 because 3 times 4 is 12. Of course, I could always think I can divide 12 by 3. Either way, it should be relatively simple. And this equation that is similar to the one we just did, except that the variable, instead of being multiplied, this time is being divided. So if we look for a number that divided by 4 equals 5, we can probably by inspection figure that is 20. Or of course, we could multiply the 4 by the 5 to arrive at the 20. Either way, these equations are rather simple. And one type that we haven't discussed is something like this. X squared equals 25. Well, if we think about it for a moment, we're looking for a number that when squared, we would arrive at 25. So chances are that we might be able to identify that number, but we can also think that we can apply the opposite operation of squaring, which is the square root. And if we do the square root of 25, we arrive at 5. So these are equations that we can solve um, almost always by just observation. Then we have two-step equations like this one. And we had a very interesting methodology that is a good metaphor using our cups and our blocks. So what we did in this case was we gradually isolated the variable on one side by removing or doing opposite operations. So first we subtracted, and whatever we did to one side, we did to the other, like the principle we talked about before, and then we end up with something simpler. 2x equals 10, and from there we can easily see that each of the x's is 5. We could divide both sides or look for a number that multiplied by 2 gives me 10. So we converted the two-step equation into a simple equation. Similarly, even if we had the variable on both sides, something like this, that appears more daunting, 2x plus 5 equals x plus 8, we have realized that this principle of subtracting or doing whatever on one side and the other is very powerful. So we could, for example, here subtract the 5 on both sides, and now our equation becomes 2x equals x plus 3. And then we also realize that whatever is under the cup is the same value. So we could subtract the cups on both sides and then arrive at our final answer, which is x equals 3. So same story, we gradually simplify these equations to make them easier to solve. And then we also extended that metaphor of the cups to do it algebraically. And so we are doing the same idea. We're making it a bit more formal, and we use opposite operations to cancel the term where we have our variable x, and we want to keep it on one side. So if we have an equation like this, 22, excuse me, plus 5x equals 2x minus 5, we can follow the same principles we did in our cups. So in this case, we can begin by subtracting the 2x on both sides. And this is another way of writing it. So now I subtracted on the left side and I subtracted on the right side. And the purpose, of course, is to eliminate that variable on the right side. So we can see that when I do this operation on the left side, I get 3x. On the right side, of course, it becomes 0. And then my equation becomes a simpler equation. 22 plus 3x equals negative 5. And then if I wanted, I could subtract 22 on both sides. It looks like this. And then when I subtract 22 minus 22 on the left side, the only thing left is 3x. And when I subtract 22 from negative 5, I get negative 27. And my last step, I could solve by inspection. I'm looking for a number that multiplied by 3 gives me negative 27. Or I can divide both sides by 3. And when I do that, I arrive at my solution, because 3 divided by 3 on the left side is 1, and negative 27 divided by 3 is negative 9. So these are the types of equations we have seen so far. And the next video, we're going to learn how to solve equations that have variables in different fashions, including fractions. But a lot of that will be built on what we just did.